In our previous video, we discussed how to receive the ethers inside the smart contract and how to send the ethers to the external address. So external address is this address. And in this video, we'll discuss how to send the ethers to the smart contract from one smart contract to the another smart contract. So let's get started. So first, let me create a contract here. So we would require two contracts. So first, let's create fallback dot sol and let's declare the contract fallback. And in this contract, we want to receive the ethers. So let's declare a function fallback. I'll explain what this function is and why we are declaring it here. Fallback. Set it to external and payable. So we know whenever we want to receive the ethers inside the smart contract, we need to set it to payable. So set it to payable, and that's it. So this should do. If we'll just set the fallback function, so we will be able to receive the ethers inside this contract. There is one more function that we need to declare, which is a receive, and I will tell the difference. Receive. Same manner, we have to set it to external and payable. And even for this function, we can leave the function body empty. Fallback function is executed when somebody tries to call a function that does not exist in the smart contract. So then it will by default call the fallback function. For example, if I try to call the send ether function, which is not available in the smart contract, so then by default it will call this function. So if we have any logic inside the fallback function, it will execute it. So the another use case of the fallback function is it can receive the ethers. By adding the payable keyword, it can directly receive the ethers from anybody or from any smart contract. So the difference between the fallback and the receive function is in the fallback, when somebody tries to send some ether, it can receive some data with it. So whenever we try to send the ether plus data, then the fallback function will be executed. And if we just try to send the ethers but no data, then the receive function will be executed. So that's the difference between the fallback and the receive function. Let's declare one more smart contract from where we will send the ethers to this smart contract. So declare one more, let's say send ether dot sol, and let me copy paste the header, and let's say contract and ether. So let's declare a function here. So do function and eth, set it to public payable. So again, we need to set payable keyword here because first we need to receive the ethers in this contract. Then only we will be able to send the ethers to the fallback contract. So set it to payable. And we will use the transfer function first to send the ethers, and then we'll see how to send the ethers via send function. So do one thing. So first we need to deploy this contract because we need the contract address. So deploy it. Now copy the contract address because we are sending the ethers to the smart contract. Now here what we can do is we can do payable. So payable, we need to typecast it to payable because the only way we can send or use the transfer function is it is only available to the address payable. So we can convert this to address payable and then do transfer. And let's say I want to send one ether. And that's it. With this one line of code, we can send the ethers from this smart contract to this smart contract because we are using this address for this smart contract. So now first we need to receive the ethers in this smart contract. So first let's deploy this contract. Okay, so before sending the ethers, let's set the get val function in both the function so that we can track if we have received the ethers or not. So here we can do function get val and do public returns uint, and here do return address. This means we want to see the balance of this address. this smart contract address, and this should do. So we can set it to view because we are not modifying anything. And let's copy this function and paste the same function in this smart contract as well, so that we can see the balance. Let's redeploy the contracts. So first we need to deploy fallback because we need the address in the send ether. So deploy this, copy the address, paste it in send ether, save it, and let's deploy send ether now. Now both the contracts are deployed. So first, let's receive the 5 ethers in the send ether smart contract. So do 5, and I have set the denomination to ether. So I want to send 5 ethers, and pay attention here. So as soon as we receive the ethers, so we are receiving the 5 ethers in the same function, it is going to send 1 ether to this smart contract. Because we are receiving the ethers in the same function and we are sending the ethers in the same function. So when we will click on the get balance function, so it will show us 1 less whatever value we have sent. So since we are sending 5, so once we'll do the get bal, so it should give us the balance 4. So let's see it in action. So right now, if you do get balance, it will show you 0 balance because we have not transferred anything. So let's click on send ether and receive the ethers in this contract. And now if I will do get balance, now it should give us the 4 ethers because we have already transferred the 1 ether to this address. Now in the fallback address, if I'll click on the get bal, so we should have 1 ether. So as we can see, we have the 1 Ethereum here. And that's how you can transfer the ethers from one smart contract to the another smart contract. Now we will see the send function. So send is no different from the transfer. The only difference is whenever we try to send some ethers with the transfer function, if there is any error, so it will roll back and it will revert the state of your blockchain. But in send, it doesn't do that. So let me try to show you the behavior. So let me try sending the ether 4 more times. And in the 5th time, when we do not have any remaining balance in the send eth function, so it should fail. So let me send 1 more. Let's see the balance. We have 2, and 1 more. We have 3, and 1 more. We have 4. Now we have only 1 left. So this time it should be successful. And you can see the transaction went through. And now we have all the 5 ethers in this smart contract. Now if I will try again, now it should fail because we do not have any balance in this smart contract now. So let's do it. And as you can see the error message here, so this has failed. So in the transfer function, it will give you the error, but let's try the same thing with the send function. Okay, so let's try sending the ether with the send function. So just replace transfer with send, and send function returns the Boolean value if the transfer was successful or not. So we can do bool, and let's do success, and that's how we can receive the value. But we have to manually check the value if the transfer was successful or not. And accordingly, we have to handle the situation inside our smart contract. So let's redeploy this contract now. Let me remove this and deploy. And now if I'll try to send the ethers, even though we do not have any balance, it won't give us any error. So you can see the balance is 0. So even if I try to send 1 ether with the send function, it won't fail. So do this. As you can see, the transaction did not give us any error. So this is a bit risky because transfer function will keep track if the transfer was successful or not. But in the send function, we have to manually keep track of it. And accordingly, we have to allow the state change inside our smart contract. So transfer and send function is no longer recommended to use inside the smart contract. The reason is because of the recent Istanbul upgrade. So the gas prices has been changed. So the reason transfer and the send function were created in the first place, they were because of the reentrancy attack. If you have not seen my video on the reentrancy attack, go ahead and check that video. Because of that attack, it caused the Ethereum hard fork, and that's how the Ethereum Classic was born. So let me show you why it is recommended not to use the send and transfer. So let's clear this and let's delete everything here. So inside the fallback function, we have to make some changes. For example, let's declare a variable here, string public and called function. So since we are using the send and transfer function and we are not sending any data, so by default, it will call the receive function. So inside the receive function, we can try to change this variable. So let's do called function and do receive function called. So we are setting the value of this variable. So send and the transfer function is restricted to 2300 gas only. So that gas can only just emit an event and it cannot do anything else. So if we try to do something else inside the receive, so it will fail. And that's the reason it is not recommended to use send and transfer, because you don't know that if you are going to send the balance to the normal external address or to the contract address, because there is no distinction between the external address and the contract address in the Solidity. So we would not know when we are sending the balance, we are sending it to the contract or to the external address. If some contract address has some kind of logic like this one, then it won't be compatible and they will fail. And that's the reason it is no longer recommended. So let's check our theory now. I can deploy this fallback contract first because we need the contract address. Copy this, go here, paste the address here, and let's define one more function so that we don't have to redeploy the contract again. So we can do it transfer, and for transfer it doesn't return anything. And also change the function send via transfer. Cool. So let's deploy this contract now. Okay, so let's first receive some balance inside the smart contract. So right now we do not have any balance inside our smart contract. So let's receive 5 ethers. And now our smart contract should have 5 ethers. So we have the 5 ethers. Now if I'll try to call the transfer function here, so it will fail because the gas that we are sending with the transfer function is just 2300, and 2300 gas is not enough to make the state variable change that we are trying to do it here. So let's try it. So call the transfer function. So you can see it has been failed. The 2300 gas can only emit a event, so which means it can just write a log, but it cannot make any state change. So on the other hand, if you'll try to send the ether via send function, even though it will fail, but it won't show you any error because we have not handled the error here, even though it is sending the false here. So we need to handle the error. So try it here. You can see it is showing the success value, even though we did not transfer the ethers there. So that's the difference between the send and transfer. And now you know why we should avoid the send and transfer function. So what is the alternate if we cannot use the send and transfer function? That we are going to discuss now. So the new recommended way of transferring the ether is the call function. So let's remove this. And instead of send, let's use call here. Call. And the way we transfer the ethers is in the curly braces will give value, and then the number of ethers you want to transfer. I want to transfer 1 ether, 1 ether, and here you can choose if you want to send any data or not. So I don't want to send any data, so that it should set the values inside the receive function. Here we are receiving 2 values. I don't care about the second value. I just care about the first one, if the transfer was successful or not. So here we can manually check the status. So just like send function, so even call function is returning the true and false status. So we have to manually check it if the transfer was successful or not. So I can do require. So the status should be success. If in case it is failed, so we should show the value transfer failed. So this message should display. So now here, let's deploy the contract again. Deploy. And I can receive 5 ethers. Let's receive 5 ethers. So the current balance is 0. Received 5 ethers. So 1 is already transferred. We have the balance of 4. And you can see we do not get any error right now, because right now we do not have any gas limitation. So whatever the remaining gas we have here, so we are forwarding it when we are making this call. So now it should have set the value inside the receive function. It should have set the called function value to receive function called. So we can check it here. And you can see here, so we have the receive function called value here. So since we did not transfer any data, so that's the reason receive function was called. So let's say if we want to transfer some data, so we have to make some changes here. So we have to redeploy the contracts again. So let's quickly do that. So I can do fallback was called, fallback called. So let's delete everything. And here as well, we want to send the values for data. So I can say calling via call function, anything that you want to send. First, let's deploy the fallback contract. Copy the address, paste the address here. Now let's deploy the second contract. And let's receive the ethers, 5 ether, and get balance. And you can see the status is success now. And the balance is 3. And let's look at the fallback now. Now it should have the value set. You can see the fallback function was called because we did send the data here. So that's how you use the call function. And this is the recommended way to use after the Istanbul upgrade. You can also limit the gas inside your call value. So you can do gas. And let's say I want to limit it to 10,000. So by defining it, I'm saying that I just want to forward 10,000 of gas. If your fallback or the receive function is consuming more than 10,000, then they will fail. And that's it about this transfer, send, and the call function. And you know the difference between all of them and when to use which function. You need to be very careful when you hardcode the gas limit inside the smart contract, unless you know what you are doing. Because by hardcoding the gas limit inside the smart contract, it is no different from the send and the transfer function. In the send function and the transfer function, the gas limit is 2300, with which we can just log an event, nothing more than that. We cannot make any kind of state change. So that was the whole purpose of using the call function in the first place. If we are restricting it with the gas limit again, then it doesn't make any sense. So let's remove it from here. The call function will forward the remaining gas, whatever gas is left here. So what do I mean by that? So let's understand it with an example. So let's go to MetaMask. And let's say I want to transfer the ethers between my accounts. So let's choose this account. Let's say 0.1 ETH, 0.01 ETH, next. And here you can see we have the estimated gas price. So wallet providers will automatically set the gas limit that we want to send or pass along with this transaction. And if your transaction is consuming less fee or less gas, the rest of the gas will be transferred back to you. And if it is consuming more, then your transaction will fail. If it is consuming more than what you sent, then it will fail because your transaction should have the sufficient gas to execute the operations. So then you see this edit button here. So let's click on the advanced options here. So here you can manually set the gas limit as well, how much gas you want to transfer. So by default, it is all calculated by your wallet providers. So if you are sending the normal transaction, then the calculations are straightforward. But when you try to execute the smart contract, your wallet provider at the backend will calculate all the gas required to execute all the operations that are there in that smart contract. Calculating gas is very easy. So in our smart contract, we already know that what all function it will execute under the hood. So we have a gas cost associated for each operation. For example, this stop operation has 0, add has 3. And based on your operations that are there in the smart contract, it will add up all the gas that is required to execute the smart contract. And that's how your wallet providers come up with the gas estimation. It's very easy to do it. And that's how they will give you the estimate that how much gas is required for that particular smart contract. So there is a function in the JavaScript which can give you the estimate that how much gas is required. So that's what they are using at the backend to get you the to give you the approximate idea how much gas is required. So now let's go back to the smart contract. So now that we are clear that how it is forwarding the gas. So for example, we have sent the 21,000 gas for this smart contract. So let's say there is one execution here. So I'll do string name Anni. So now when we created the transaction, we have sent 21,000 gas with that transaction. So let's say it executed the first line of code, and out of 21,000, it consumed 1,000. This is just an example. This is not the fixed gas that I'm telling you that this operation will take, but this is just to help you understand. So now that we have executed that, so now we are left with 20,000 gas. Now that 20,000 gas will be passed here. So that's how the call function is passing the remaining gas to the fallback function or the receive function when we call it here. And in the transfer and the send function, because the gas is limited, so we cannot perform any other operation inside the fallback and the receive function apart from just writing a log, nothing more than that. So that's about the send, transfer, and the call function. And I hope you are clear that how they work under the hood.